In this video, you will learn how to analyze a position time graph. So you are given a position time graph. So here you have a time along x-axis and the position along the y-axis. And as the time passes by, the position is not a constant, it is changing with respect to the time. So this person is moving very steadily, all with a linear velocity, let's say along x-axis, and then here in this region he stops and then start to move in the opposite direction, and here it just comes back to its starting point and then again past the starting point in the opposite direction, stops and again starts moving in the positive direction, positive x-axis, and again stops here. So this is the how the person was moving with respect to the time. So from this graph or from this information, we're going to calculate the total distance traveled between time equals to 0 second and time is equal to 50 seconds. So let me circle that. So this is my 0 second and this is my 50 second, and between these two time we have to calculate the total distance traveled. So let's go over it. Between these two time window 0 to 25 second, the object has moved 50 meters. So this is 50 meter here. You can clearly see at 25 second what is the corresponding position, that's the 50 meter. So if I have to write down, so the time, so 0 to 50 second, so 0 to 25 second, 0 to 25 second, the distance covered is 50 meter. Okay, and now from 25 to 35, 25 to 35, so this person has not moved at all because the position is not changing here. At this point the position is same, at this point the position is same, at this point the position is same. So the position has not changed. So the distance moved in this region is 0 meter. And now let's go over to the from 25 to from 35 to the 50. At this point the position was 50 meter. So this is 50 meter, this point, and at this point, as corresponding point here, this is minus 10 meter. Okay, so at 50 the position is minus 10 meter. So now what is the total, the distance traveled between these 2 points, between the point equals to this point and this point? The total distance travel is 50 plus 10. Remember, the distance cannot be negative, the distance is always positive. So this is the actual path you travel. So this is the actual path you travel, in fact. So the total distance covered between the time 35 to 50 second is 50 plus 10, which is 60 meter. So altogether if you add 0 to 50 second, the total distance travel is 110 meter. Okay, so here is the answer. So the total distance travel, so distance T or travel is 110 meter. Okay, so now we found out the distance. Now let's calculate the displacement. So here we are again going to find out the displacement. Let's find the total displacement. Displacement traveled time equals to 0 and 50 second. So again, within this window, we're going to calculate the total displacement. How are you going to find out? In order to find out the total displacement, all matters is what is your initial position and what is the final position. All that matters. It doesn't matter what is happening in between. So let me circle the 0 and the 50 second. All that matters is these two position. So at this point, time equals to 0. Time equals to 0. My position, that is my initial position, I can write down here is 0 meter. That was our starting point. And at time equals to 50 second, that is my final position. And that my final position, if you look at this final position, it is minus 10 meter. All matters is this. So the displacement by definition, is final position minus initial position. My final position is negative 10. My initial position is 0. So my total displacement is now 10 meter, negative 10 meter. And what does the negative sign tell you? What does the negative number mean here? The negative number simply means you are on the opposite side. You are on the opposite direction. So if I call this as a positive x-axis, a positive y-axis, then you are on the negative side. Or let me explain here this way. So let's say this is your starting point, and this is your forward direction. That means the person after 50 seconds, you ended up being at a 10 meter on the left side here. That's what it means. This is a positive x-axis. So that means after 50 seconds, you are on the left side of it. All right, so this is the total displacement of negative 10 meter here. So the displacement here is negative 10 meter. Okay, so we got this part here. Now we're going to find out the instantaneous speed and the instantaneous velocity at a certain time. So let's calculate here. Let me erase these things. Oops. So let's calculate now the instantaneous speed at t equals to, let me see here, let's call it at 45 second. Let's do this one. Okay, so here I'm going to again circle this one. So here we are interested in finding out what is my speed at this point. So this is a position time graph. How would I find out my speed? How fast I was moving at that point? So remember, if the graph given here is the position time graph, then the slope gives you the speed, or in fact it gives you the velocity too. So here our goal is to find out what is the slope at this point. So it doesn't matter where you measure the slope at this point or anywhere in between, the slope would be exactly the same because it's a linear line. So our goal is now to find out the slope of this line. And remember, if I measure the slope of this line, that at any point my speed would be exactly the same because it's a perfect linear line. So let's find out the slope of this line. Okay, the slope, remember the formula for the slope is, I'm going to use other color. The formula for the slope is a rise over run. The rise over run. Okay, so here just to make life simpler, I'm going to use this segment here, and in this case my rise is this length here. That's my rise, and my run would be this length here. This should be my run. Okay, so this all I have to find out. Oops. Okay, so all I have to find out is this length and this length here, the rise. So you can clearly see here, this point corresponds to the 50, this point corresponds to 50, and this point corresponds to negative 30. So the total length of this one, total length of this line would be 80. And the reason is this is 50 and this is 30. So if I add them together, the total length would be 80. And run, the run is this segment here, and this is 35 and that is 55. So the total, this length of this one would be 55 minus 35, which would be 20. So this is 55, this is 35. So if we take a difference, that would be 20. So here is 4. So what does this mean? The 80 here is this length here, that is meter, the meter. So this is in meter, and on x-axis this is in second, so that is in second. So my speed would be 4 meters per second. That is my speed at this point. Okay, so speed, and this is instantaneous speed. And one more thing here, to at any point in between here, at any point the speed would be exactly the same, because it had the same slope at any point here, or the object was moving with a uniform speed. Okay, so we got this part too. So the instantaneous speed at that point is speed equals to 4 meter per second. Okay, so now let's calculate the instantaneous velocity. So here, instantaneous velocity. Velocity at the same time, 45 seconds. So here the instantaneous the velocity at that point would be exactly the same velocity would be simply equal to negative 4 meter per second. And why I've chosen the negative sign here? The negative sign simply tells you the slope is negative here. So remember, if the line is this, then this is a positive slope, and if the line is tilted towards the other side here, so that is the, or if it is greater than 90 degree, then the slope would be negative. Okay, so here the slope is positive, the mountain, or you can see it is going up, and this one is going down here. So this is the positive slope and this is the negative slope here. All right, so that means the instantaneous velocity would be negative, or you can find out in a different way here too. So now let me find out how you're going to find it out, why it is a negative slope. So this is my initial position and this is my final position. This is initial position and this is my final position. So what is the instantaneous velocity, or in this line, average velocity is exactly the same as the instantaneous velocity, because it is the same line here. So the final position is negative and the initial position is positive. So if you take a difference and then calculate the average velocity, it would be negative. So in any case, as the slope here is negative, so you will have the negative 4 meter per second as the instantaneous velocity at time equals to 45 seconds, or any time on this line here. Okay, so now the one other part we're going to calculate is average velocity. Average velocity between time equals to, let's say 0 second and time equals to 60 seconds, we're going to find out the average velocity. Okay, 0 and 60. Okay, so let's circle that. Where is 0? Here. And where is the 60 second? And we have to find out the average, the velocity. What was my average velocity? In order to find out the average velocity, all matters is your initial position and the final position. All matters, that is. So average velocity we denote it by this line here, and the way it is defined is my final position minus initial position divided by the final time minus initial time here. Okay, so let's find out our final position. So the final position here at which is this time at 60 seconds is this position, and if I look at on the graph, this is -30. So my final position is -30. And why is that? Because we are interested in calculating at time equals to 60 seconds. So at time equals to 60 seconds, my position is -30. Time equals to 0, my position is 0. So the time, final time is 60, initial time is 0. So if I do the math, then I will get -0.5 meter per second. Okay, so that means the average velocity between these 2 points is -0.5 meter per second. And this makes sense because if you look at the final position of the object, it is onto the opposite side here on the opposite side here. Okay, so that is the average velocity. And now let's calculate the average speed in between. Average speed. Okay, so let me write down the answer here. -0.5 meter per second. So this is -0.5 meter per second. And then make sure that you have all the steps written down here, not just the final answer, all the steps showing how did you get to this answer. Okay, so now I think this is the last one to calculate the average speed. And time equals to, let's say, 60 seconds. We have to calculate the average speed. What does it matter to calculate average speed? What information we need? All the information that we need is what is the total distance traveled. So here I am circling 0 and 60. So I'm going to calculate the total distance traveled. So from this point to this point on this length, the distance traveled is 50 meter. Here it has traveled no distance at all, so 0 meter. From this point, from this location to here, the distance traveled, this one is 50 here, and here it is 30. So in this case it has traveled 80 meter. And from this point to this point, there is no distance travel. So the total distance travel is 50 plus 80, and that would be 130 meter. 130 meter. So we have found the total distance travel from 0 second to 60 second. So once you know the total distance travel, then the average speed that we denote by S bar, that's the average speed, is the distance divided by the time. So what is the distance? The distance is 130. And what is the time? The time is 60. So let's divide these two numbers. 130 divided by 60. And you'll get 2.16, or I can simply call the 2.16 2.17 meter per second. Okay, 2.17 meter per second is your average speed. So average speed is 2.17 meter per second. And now if you look at all these, the information we have, the one thing you must be convinced that average speed is always greater than the average velocity, okay, and the distance traveled is always greater than the displacement. Okay, so just make a note here. So the distance is always greater than or equal to displacement, and average speed is always greater than or equal to average velocity. So this was it from this video here. Hope you learned from something from this video, and you must have gained confidence how to calculate the average velocity, instantaneous velocity from a given position time graph. Thank you very much.